Hello people, this is Sana Parveen here and welcome to Sana's Biochemistry. In this video, we are going to talk about a chapter which is there in 10th standard called as carbon compounds. So this carbon compounds, we're going to talk about this chapter and we will start from the starting. Okay, we're just going to go in a sequence. The first topic that we will be taking, okay, fine, whatever we see, the things that are present around us, be it vegetables, be it something called as the fibers, be it vegetables, be it papers, be it furniture, medicines, fuels, smoke, whatever. There is one element common in it. All the things that we see here, there's one element common in it, and that is called as carbon. Why is carbon so important, and why do we focus on carbon compounds, or why do we study it? It is because day in and day out, night, day, your everything from your head to your toe, from your surrounding, everything which is present around you, in you, okay, everything is made up of carbon. Okay, these all things comes in our day-to-day life. Okay, let me just select a pen. All these things are, if we have taken it from day to day life, we need medicines on a regular basis, furnitures, papers, without which we cannot do anything, fibers, vegetables, and fuels. All these things, they've got one thing in common, which is called as carbon. Okay, so it is a very very important element, because of which it becomes very necessary for us to study about this element called as carbon. Okay, now this carbon has got two important things which we need to discuss: 6 and 12. What are these numbers? Consider there's a person in a class. This person is going to have a roll number, and this person is going to have a particular weight. Okay, for example, roll number 1 has weight 50 kgs. Okay, roll number 1 has got weight 50 kgs. The same thing is with the carbon here. Carbon has got an atomic number which we represented by Z. Atomic number of carbon is 6, and mass number, which is denoted by A, of carbon is 12. So mass is 12 and atomic number is 6. Atomic number is like the roll number which the student has, and mass number is the weight. Okay, as we've considered in the example. This carbon is extremely important for us to study. And in here we have the, it's an element. It is a part of the periodic table. There are other elements also which are used in various things, which are used in various things in here. So carbon hai, nitrogen is there, oxygen, fluorine, everything is there, out of which we're just going to focus in here, which is called as carbon, because we're going to study about carbon compounds. This carbon already we've seen. Atomic number is 6 and mass number in here is 12, so we're not going to discuss that again. Okay. Electronic configuration. When I say that the atomic number of carbon is 6, what did I say? Atomic number of carbon is 6. What do I mean by that? I mean that it has got 6 electrons in it. Okay, there are 6 electrons in it. If I've got 6 electrons with a carbon and I try to draw the structure of carbon, we all know that there is a nucleus present in between. So I write it to be the nucleus, and then we have got electrons surrounding the nucleus. When I say there are 6 electrons in carbon, I have to draw 6 electrons: 1, 2, okay, 3, 4, 5, and 6, because the capacity of this one is to hold only 2 electrons. Okay, the capacity for this is to hold 8 electrons. Okay, fine. Now we have got only 6. I have put 2 electrons in the inside. Okay, there were 2 electrons in the inside and 4 electrons on the outsides, on the outside. So we have got the configuration to be 2 comma 4. The electrons which are present on the outside are called as valence shell electrons. So we've got 4 electrons in the valence shell of this element called as the carbon, the famous one. Okay, there's a concept called as noble gas configuration. This is important for us to understand what noble gases are. Noble gases are helium, neon, argon, krypton, xenon, radon, etc. Helium has got 2 electrons. Okay, neon has got 10 electrons. Configuration is going to be 2 comma 8. We're not going to talk about argon, just helium and neon. When I talk about this, what is noble gas configuration? That means any other element, if they attain the configuration like this, okay, in the outermost shell 2 electrons, or in the outermost shell 8 electrons, we say the elements have reached noble gas configuration. Because these noble gases, this is neon, not nitrogen, it just got erased. Helium 2 noble gas, this is the noble gas configuration, because helium and neon, they're noble gases. Configuration means distribution of electrons. The helium atomic number is 2 and the configuration is 2. Neon atomic number is 10, so configuration is 2 comma 8. We say any element will attain noble gas configuration when they have got 8 electrons in their outermost shell. Okay, now when I consider this thing, again the same thing is written here, helium 2 and neon 2 comma 8. What did I say? Any element, if they have got, let me just write it here because I was space here. If I say I have got carbon, and carbon atomic number is 2 comma atomic number is 6 and the configuration is 2 comma 4, I don't see carbon having 8 electrons in the outermost shell. Okay. If the carbon wants to be stable, if this carbon wants to be stable, it has to have 8 electrons in the outermost shell. If 8 electrons are present in the outermost shell, the carbon is going to become very, very stable. And we say that carbon has attained noble gas configuration. Okay. So we have two things. Either we go to the helium configuration, that is 2, or we go to neon configuration, that is 8. So what will I have to do if I have to reach to this configuration? Let me just select here. Okay, if I have to reach to this helium configuration, I know the configuration here for carbon is 2 comma 4, again 2 comma 4. If I have to reach to helium configuration, I'll have to lose 4 electrons. Yes, I have to give out 4 electrons, minus 4 electrons. Okay, when I lose 4 electrons, there are 4 positive charge generated on the carbon atom, C4 plus, because I've lost 4 electrons. If that is not the case, and if I want to, attain the noble gas configuration for neon, here I have to add 4 electrons. Yes or no? Yes, definitely. 4 electrons, that means 2 comma 8. When I add 4 electrons, it is definitely going to be 8. When I add 4 electrons, there are additional 4 negative charges generated. Okay, and then I end up getting C4 minus ion. When I have got a positive charge on the carbon, I call it to be carbocation. And if I've got a negative charge on the carbon, I call it to be carbanion. Okay, but then losing 4 electrons losing to have 4 plus charge, and gaining 4 electrons to have 4 minus charge, it is an energy requiring process. Okay, it requires energy. Fine. 4 electrons have to lose. There is involvement of energy. Let us just forget about requirement is there or not. Let us just not discuss about this. It has something to do with energy, and the carbon is not having that much of energy to form cation or anion. That too with 4 charges. See, anything which have got charges is definitely what, not stable, and 4 charges are definitely a higher number of charges. So we have to make carbon stable. With 4 charges, the carbon is definitely not going to be stable. So what the carbon does is, it makes a it makes a smart move. What it says, if I cannot lose 4 electrons, if I cannot lose 4 electrons or gain 4 electrons, I go for a middle road, which is called as share. Okay, it will go and ask to the other elements to share the electrons with it. Okay, so it is going to go for sharing of electrons. When the atom carbon goes for sharing of electrons, the chemical bond is formed. A chemical bond is formed by sharing of electrons, and this type of bond is called as covalent bond. Okay, let us just now see carbon with 4 electrons in its outermost shell, 1 2 3 and 4. Okay, it is going to go and have a talk with hydrogen, so as to have hydrogen has got one electron, another hydrogen one electron, another hydrogen one electron, and we've got one more electron. So after sharing, what happens is carbon in its outermost shell is going to gain how many electrons? 8 electrons. Okay, let us just count 1, 2, 3, 4, 5, 6, 7, and 8 electrons are present here. When 8 electrons are present in the outermost shell of carbon, we say carbon is now stable. Carbon has gained the noble gas configuration, and this is possible only by doing what? Only by sharing of the electrons. So carbon will not go for losing the electrons, neither it will go for gaining of electrons. It is definitely going to go for sharing of electrons. And the bond which is formed here, so let me just redraw it again. Carbon, hydrogen, 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 and hydrogen. These bonds which are present is called as covalent bond because it is formed by sharing of electrons. Okay, now we've got something to understand what covalent bonds are. Hydrogen is there with one electron, there's another hydrogen with one electron. Okay, we say they have to attain noble gas configuration, so definitely hydrogen is near to helium. Helium configuration is 2. Hydrogen is a small atom. This is going to share one electron with it, and this is going to share one electron with it. These two electrons belong to this hydrogen also, these two electrons belong to this hydrogen also, because they're sharing things. Okay, when you share, it is not completely yours, it is of the other person as well. For example, we have got two friends, friend number 1 and friend number 2. They're sharing a pen. Okay, they're sharing a pen, so the pen is belongs to this person also and this person also. The same case is with the hydrogen here. Hydrogen, after sharing the electrons, forms a bond between them, and there's formation of a covalent bond in hydrogen molecules. The way of writing hydrogen molecule is H2. Next thing is with the case of oxygen. After sharing electrons, after sharing electrons, it has got how many electrons? Now let me draw. These are the electrons of this oxygen, and these are the electrons of this oxygen. When I count here, these electrons, these are 4. 1, 2, 3, 4, 5, 6, 7, and 8 electrons are present. When I count these electrons, I again have how many? I have got 8. 1, 2, 3, 4, 5, 6, 7, and 8. That means oxygen has attained noble gas configuration. Okay, after attaining noble gas configuration, it goes for a double bond because that many sharing of electrons was required. Oxygen was having 6 electrons. How many electrons was it having in the outermost shell initially? See, oxygen is 8, 2 comma 6. 6 electrons in the outermost shell. So I draw 1, 2, 3, 4, 5, and 6. This other oxygen again 1, 2, 3, 4, 5, and 6. So two bonds are to be formed for having 8 electrons for reaching the noble gas configuration. So there's a formation of a double bond, two covalent bonds between oxygen and oxygen. Next here is nitrogen. Let us just consider this as an example. Nitrogen 7, atomic number 2 comma 5. I draw one nitrogen here with 5, 1, 2, 3, 4, and 5 electrons. Another nitrogen is going to come help this nitrogen 1, 2, 3, 4, and 5. Okay, if 5 electrons are there, we need sharing of 3 electrons. So we go for sharing of 3 electrons. Sharing here. Now I count 1, 2, 3, 4, 5, 6, 7, 8. Okay, this nitrogen is happy. What about the other nitrogen? It again has 8 electrons. Okay, it again has 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Both of them are happy. Because of the sharing, the triple bond is formed between nitrogen and nitrogen, and there are 3 covalent bonds. 3 covalent bonds. Covalent bond is formed by sharing of electrons. So we saw in case of hydrogen, there is one bond. In case of carbon, in case of oxygen, we saw double bond, and in case of nitrogen, we saw a triple bond formation. Carbon, when we say carbon go for sharing of electron, we've already seen this structure. Okay, previously in the video, you can go back and rewind that. This structure is called as methane, and methane has got how many covalent bonds? How many covalent bonds in methane? Let me know in the comment section. I won't tell you. So methane structure is formed here by sharing of electrons between carbon and hydrogen. And these are different ways of representing methane molecule. This is called as ball and stick model. This is called as space filling model. There are different types of models for, giving the molecule methane structure. And this was all about the video. We've covered a topic from 10 standard carbon compounds. It's an important topic, and we'll be making more videos on that. If you haven't subscribed to the channel, subscribe to the channel and keep visiting the channel. Share it with your friends. Stay safe at your homes. Take good care of yourselves, and see you in the next video. Bye bye. Take care, everyone.